On number 11, we need the least amount of force you can use to do this job. That is going to be 90 degrees because everything else is kind of wasting effort. Torque is force R sine theta. Please put R in there. And then we get tau over R sine theta. Sorry. So the force is equal to the torque needed over the radius of the wrench in meters. That was easy, it was given to us. And the sine of the angle being used, and you end up with 50 newtons. In 12, they give you the force, the angle, they give you the angle and the radius from the center of the bolt, and they want you to calculate the torque. Please, again, add in an R here. And that is R there. And you just have force times radius times sine of 70. I suggest you start here because otherwise you end up with a bunch of parentheses. So sine of 70 degrees times this should give you a torque of 10.3 Newton meters. A propeller spins at 3,000 revolutions per minute. What's the angular velocity in radians per second? We did that, a good bit of that up top. It's 3,000 revolutions per minute. I know that there are 2 pi radians for every revolution. This cancels out the revolutions and gives me radians. I don't want minutes, I want seconds. Flipping 60 seconds per minute over gives me seconds on the bottom like I want and cancels out minutes top to bottom. 3,000 times 2 pi divided by 60 should give you 314 radians per second. On 14, the explanation is that if an object is floating in space and headed in a constant direction, then it has no acceleration. If it has no acceleration, by F equals ma, it has no force. No force is being used. And without force, it is impossible to do work, new work. So no force is being used, no work is being done. What's the common definition of energy? The ability to do work, because energy is not visible in the way that matter is. So it has a bit of a vague explanation, but you can't do work without energy. What are the simple machines? It's just a memorize it question, kids. Screw, ramp, wheel, axle, pulley, lever, and the one I forget the most, wedge. What machine has an efficiency of 100% and why? None, because with any work done, there is always a little bit of heat lost that can never be recovered.